Hello, my name is Alex Gross, and today I'll be talking about the Toyota Hybrid Synergy Drive System and giving you an outline of different components and what goes into the system. First, I want to talk about all the different Toyota hybrids that are available at this time. Currently, there are 7 Toyota branded hybrids, including the Prius, Prius C, Prius V, Prius Plug-in, Camry, Avalon, and Highlander. And for the Lexus brand, there are 6 that include the CT, NX, RX, ES, GS, and LS branded models. In 2016, Toyota will be introducing a hybrid RAV4 and making it a total of 14 available hybrids between the two brands. The Toyota Hybrid Synergy Drive system is made up of 4 different components: the internal combustion engine, the transaxle, inverter, and hybrid vehicle battery. Each of these components work together to provide an optimal efficiency for every driving condition. The following slides will break down each one of these components further and give you a basic understanding of their operation and purpose. The internal combustion engine on a Toyota hybrid is very similar to non-hybrid engines, except that it has a few extra jobs. Now the engine can power MG1 or motor generator 1 to produce electricity to recharge the HP battery. It still drives the wheels and also is shut down at certain times for optimal efficiency and fuel mileage. The transaxle assembly contains 3 major components that drive the vehicle: motor generator 1, motor generator 2, and a compound gear unit. Each motor generator is attached to the compound gear unit, including the internal combustion engine, that work together to drive the vehicle through the final drive gears. The illustration on your right shows the placement of each of the components within the transaxle casing and what each component hooks to. Now that you've seen where each motor generator is located within the transaxle, let's talk about what each one does. Motor generator 1, or MG1, recharges the HP battery when it is turned by the gasoline engine. It supplies electrical power to MG2. It modifies the transaxle's output, and it also starts the internal combustion engine when signaled to. Motor generator 2, or MG2, works with the internal combustion engine to drive the wheels. It converts kinetic energy into electrical energy during braking to recharge the HP battery, and it also drives the vehicle in reverse because there is no drive gear in the transaxle assembly. Motor generator rear, or MGR, works very similar to MG2, but is used in 4-wheel drive applications. It is mounted in the rear of the vehicle, and it still converts kinetic energy into electrical energy during braking to recharge the battery and drives the rear axle only. The compound gear unit is what connects the internal combustion engine, MG1 and MG2, to the final drive and the wheels. It is made up of 2 sets of planetary gears, and it shares a common ring gear that drives a counter gear that drives the final drive. It reduces the MG2 RPM and increases torque output to the wheels. It also balances the engine in MG1, and MG1 also controls the output of the compound gear unit. The illustration on the bottom right shows the component location and what each member is hooked to. The inverter assembly, also known as the power control unit, is the heart of the hybrid system. It locates between the hybrid battery and MG1 and MG2. It also modifies and provides electrical voltage to other various systems and components. Mainly, it drives the electric motor and recharges the battery. It contains an MG ECU, which controls the functions of the inverter and the charging of the battery. It also contains a boost converter, which can boost the electrical voltage outputted to the electric motors up to 650 volt DC maximum. Inside the inverter is also a DC to DC converter. This controls the charging of the 12 volt system and provides a stable 12 volts for all the 12 volt components on the vehicle. The HP battery stores electrical energy for the hybrid system. It is a nickel metal hydride battery that has voltage ranging between 201 to 288 volts DC depending on the model. It's recharged through regenerative braking by MG2 and power generated by MG1 when it is turned by the gasoline engine. Each cell in the battery produces 1.2 volts DC, and it has its own isolated cooling system to monitor the battery's temperature and keep it at a certain rate for optimal efficiency.